Now let us consider assembly of charges. Assembly of charges. Since potential is a scalar quantity and follow the superposition principle, on the basis of that we can say Vp will be equal to the Vp1 plus Vp2 plus Vp3 and so on for Vpn. If we have assembly of charges like that, no need to draw the figure, you can visualize the image, and in that case we can write the potential will be I is equal to 1 to n. We can write this in summation form like that, and it can be written as I is equal to 1 to n. V can be written as Q by 4 pi epsilon Ri. Now let us try to find the relationship between E and V, and it will be, we know potential difference is E dot dl in integral form. Okay, we can write change in potential will be E dot change in length. Okay, so what we can say, it can be written as minus E change in length cos alpha V. We can write like that. So from here we can write cos alpha times E will be equal to the minus change in potential with respect to change in length. Okay, from here if we can say change in length can be written as dl for small change, and in that case change in potential can be written as dv. This is only when change in length del L tends to 0. In that case we can write, okay, no need to, in that case we can write, and from there we can say E cos alpha will be equal to the minus dv over dl. Okay, so this will be maximum when alpha will be alpha will be 180. In that case it will be minus and it will be okay. So when alpha is equal to 180 degree, okay, then dv over dl will be maximum. Okay, so it means L should be in opposite direction to the movement of the charge, and it means L should be in opposite direction. In opposite to E, and if the both are in opposite direction, then potential energy will increase, and if potential energy will increase, then potential will increase. So we can say potential will increase. Okay, so what we can say, dv over dl becomes equal to E, when alpha is equal to 180 degree. Now dV over dl will be E when alpha is equal to 180 degree, and that is the maximum rate of change. And in calculus, in the beginning of this chapter, we have studied that the gradient specifies the direction of maximum rate of change. So according to that, we can write the gradient of V. Okay, so we can write E is equal to gradient of V because it specifies the maximum rate of change at 180 degree when both are opposite. The displacement and the direction of field will be opposite. Additionally, there will be minus charge because we know electric field is directed from higher potential to lower potential. So negative should be there. So we can write regarding that minus is because we can say how we can write electric field is directed from higher potential to lower potential. Lower potential. That is why there should be negative. And E will be gradient of V because gradient maximizes the rate of change. That is when E and displacement are in opposite direction. And this is called the differential form of relationship between E and V. Okay. Now we can write VAB is equal to, we have done it, from A to B E dot dl, it will be VB minus VA. And if we write VAB like this, then we can say that it depends on the final point B and initial point A. So regarding this one sentence, we can say VAB is independent of the path from A to B. It just depends from the final position to initial position. For example, this is point A, this is point B. Moved like that, moved direct from A to B, moved, followed this route X, Y, Z. In this case, you can say E dot dl, according to definition, E dot dl will follow path AXB will be equal to the E dot dl followed path AZB. In both the cases, it will remain same. Okay. So if in this way both will remain same, then what we can write? Minus E dot dl AXB plus AZB E dot dl we can write, okay, is equal to 0. Further we can write, you can write BZA with negative of this, or here we can write BXA with negative of this, that will be positive. So if we are moving from A to B, then AXB will be there. If we are moving from B to A, then BXA should be there, and the sign of this will be reversed. So following that, we can say E dot dl from BXA plus AZB E dot dl will be equal to 0. What we can observe there? AZB and here BXA. It means from here. Now it came to know that in closed loop the potential difference is equal to 0. It means from here we can say E is conservative, okay, in a closed system it remains conserved. So according to that, E dot dl in a closed loop will equal to 0. Now according to Stokes theorem, we can say E dot dl in a closed loop can be equal to the del cross E dot ds over a surface. It must be equal to 0 according to Stokes theorem, and it is irrespective of the curve. So from here we can say del cross E should be equal to 0. This is the differential form of conservative law of electric field. So we can say differential form of conservative law, okay. So from here we can conclude E remains conserved and second thing, as cross product is equal to 0, so we can say electric field is irrotational. In curl we have studied this. Okay, so from here two conclusions can be drawn. E is conservative and it is irrotational, and this is a differential form of conservative law of electric field. And from the Gauss law we know this, and from here if we write in terms of E, then we can say E will be equal to the rho by epsilon, and from the potential difference we can write in a closed loop, you can write like that. So this is the presentation of electric field nature of conservative as well as irrotational. And if any field is given there and we try to find the curl of that field and it is not 0, it means that given field is not electrical field, that is something else. So to identify that the given field is electrical field, it means the curl of that field will be equal to the 0. So in this way it may be asked in the exams that try to find the electrical field from the given options. So in that case you have to just find the curl of those options, and among them which one will give you 0, that is the electric field. Let us solve one example to find the potential difference. The example is E is given here in Cartesian coordinate system, and now we have to find the potential difference when we are moving from point P to point Q. P point is given here, the coordinate is -7, 2, 1, and the Q coordinate, point of Q coordinate is given 4, 1, 2. So we have to move from P to Q, and to move it from here to here we have to find the potential difference. So first of all, to find the potential difference, we know that E can be written as, V can be written as E dot dl. We know this. If we have E, then the only parameter that is required to find the potential difference is from P to Q. The only parameter that is required to know V is dl. And in Cartesian coordinate system, dl can be written as dx in the direction of x, dy in the direction of y, and dz in the direction of z. So we have to find dl, dx, dy, dz. Okay. So let us do that. Solve this. E is given as -6y by x square in the direction of ax, plus 6 by x in the direction of ay, plus 5az. Now we will do dot dl, dx ax, plus dy ay, plus dz az. Now integrate this. Now let us integrate, just do dot product, then integrate this. It will give you minus for all. So you will get -6y into 1 by x square into dx. Integrate this, plus 6 by x dy. Integrate this, because the dot product of this with this will give you 1, and remaining with this and this, the dot product of this will give you 0. So this term will be available, this term will be available, plus 5z, 5dz. This term, just concentrate here. We are moving here, we are moving in the direction of ax only. So it means x will change and remaining things will remain same as it is at point P. So y will be equal to 2 and z will be equal to 1, and x will change from -7 to 4. Hope it is meaningful to all of you, because we are moving in the direction of x only. We are moving from -7 to 1 to in the direction 4 to 1. So 4 to 1 will be just x is equal to 4, y is equal to this point 4, and z is equal to 1 here, somewhere here, half of this. So this will be point 4 to 1. So on the basis of that, just we are changing the x position and remaining will remain same. So this will be proper way. And when from here we are moving towards this, because from this point we have to reach to this point to find the DL. So first we moved in this direction, then we will move in this direction, then in this direction. And for this, when y is changing, so from here when we are moving, then only y coordinate is changing, x remains same. So x is how much here at this point? X is 4, and what is z? Z is equal to 1. What is changing? Y is changing from 1 to 2. From 2 to 1. At this point y is 2. So y is changing from 2 to 1. Hope it is meaningful. Now we are at this point. Up to this point, up to here we are at this point. Now we have to move from here to reach the final point Q. So in which direction we are moving now? We are moving in the z direction only. So to move in the z direction, x and y remain same, and at this point x is how much? 4, and y is how much? 1, because at this point y was 2, at this point y is 1, and z is varying from how much, from where to where? Z is varying from 1 to 2. Hope it is clear to you all. Now simplify this. It will give you minus 6y by minus x, because dx by x square will give you minus 1 by x, and it is x is varying from minus 7 to 4, keeping y constant, plus 6 by x, y is varying from 2 to 1, keeping x constant, and here 5 z, where z is varying from 1 to 2, keeping others constant. In continuation, just write how much it will be. Y is constant, that is 2, 12 times 1 by 4 minus 1 by 7, okay, plus 6 by x is 4, y will be 1 minus 2, plus 5, z will be 2 minus 1, 1. Okay, now simplify this. After this simplification, we can say it will be quite difficult. 12 into 11, 28, minus 6 by 4 plus 5. Now solve this, you will get the final answer. So it will be old, we will be this.